And we're back. Excellent. Okay. First things first. First things first. We are back, and I don't know if you guys are planning on having any more super spreader events with each other. No? That's why we were quarantined for 2 weeks.
I'm having a birthday party.
Anyway, but yeah, we're back, and I don't know how long we're going to be back for. Hey, but you know what? The numbers in New Jersey are actually getting a lot better. The numbers in New Jersey are now averaging about 2,000 to 3,000 cases a day, which if you go back to like November, December, we were upwards of like 7, 8, 9, 10,000 cases a day. Now we're back at 2,000 to 3,000. We're getting back to basically we're at a level that we were at last October. Do you remember last October where we didn't actually need these dividers? Yeah, we're at that level kind of right now, but we still have the dividers for some reason because people are still kind of like, ooh, okay. To make you feel like you're something? I don't know. Regardless. Next. You do have an assessment that is due for you guys. I'm just double checking this right now. You have a major assessment that is due tomorrow. I assigned it to, when did I assign it? I assigned it a while back, right? No, definitely not Saturday. I assigned it on the 18th. Yep, Thursday. Thank you. Thursday. But several people have already submitted it. Make sure that you are doing that. If you haven't already done that, there go my glasses because my daughter broke them. Yeah, no, my glasses right here, dude. They got broke. They keep falling off my face.
I thought I saw something different.
It's my winning personality. Minus 10. Anyway, so next. This is important though. Besides the major that is due tomorrow, make sure you get it done. Wednesday. I will not be here on Wednesday. I will actually be driving off to Rowan, near Rowan University Medical Campus Center, whatever the thing is called, to go get the first dose of the vaccine so that I will have superpowers. Okay? No. I'm going to get the vaccine, and I'm going to be able to lift cars over my head. That's how it works. Yeah. Okay. But even though I will not be here on Wednesday, you are still going to have something to do through Google Classroom. And this is especially for those in the live stream right now. On Wednesday, I will not have a live stream, obviously, because I will not be here. So, my glasses. For those of you in the live stream, you are going to have to sign on to Google Classroom to get that assignment done in order to count for the day. So please make sure you're bringing your Chromebooks, because I don't know who the heck is going to be in here. I put in for the absence last week, but I don't know how many substitutes have you actually seen this year? Not that many. Yeah. I have no idea whether or not they're actually going to get a substitute or if they're going to pull a teacher in or whatever. Yeah.
My chem teacher retired, and there's been like 4 different teachers just like jumping on the Google Classroom.
Yeah.
And I'm like, who are you?
I know. I don't know.
They like email my mom saying I'm not joining the meet. But then when I go to join the meet at the time, there isn't one.
Yeah, she retired. Yeah. Good for her for retiring. She was going to retire at the end of the school year. But yeah. But anyway. My point is, I won't be here on Wednesday. Don't fret. I'm alive. I'm not sick. I just will have superpowers to throw things at you. Anyway, for those of you in the live stream, I only see 1 comment so far, but if you would in the live stream, if you would leave a comment in the chat, that would be fantastic so I can see that thing there. That'd be wonderful. Please go ahead and do that when you get the chance. Here's what we're doing today. All right. Shh. Here's what we're doing today. You have a major assessment due, but today, I'm going to introduce to you the new chapter. I know, I'm so hyped. So here's what's going to happen. In order to introduce this new chapter, I need to do a little bit of an experiment. And this experiment will be you making a choice between two distinctive plans. I am, in a little bit, going to present you a plan A and a plan B, and you are going to have to choose whichever one you believe is best. Now, in order to actually make this choice, so I don't have to collect anything from you, I am going to create a Google form that I am going to make available to you through the Google Classroom, and you are going to answer plan A or plan B through that Google form. So, what I'm going to do is I'm going to present to you the plans first. Then I'm going to ask if, for you guys to get on the Chromebooks to do that one quick thing, and then we'll shut the Chromebooks down. Yes? Plans. You'll see. When I explain them, you'll see them a little bit better. So, imagine for a moment that we are back in September. Imagine that there is no COVID. We're actually here in the classroom. It's day one of the school year. You walk into my classroom and I say, well, I grade things a little bit differently. The way that I grade things is purely 100% by homework. There are no tests, there are no quizzes, but you have to get the homework done. And I will be grading it. I won't be just doing it for completion. I will be grading it. Whatever you turn into me, I will grade correct or wrong based on every single problem and give you an appropriate grade. And that's what 100% of your grade will be made up of. That's the deal. But I'm going to give you an option. You get to choose between plan A and plan B. Now, whatever plan you choose, you are stuck with. And you have to stay with for the entirety of the 36-week school year. That's the deal. So, let me tell you what the two plans are. So, plan A is this. Every week, you have 5 hours of homework. Now, when I say 5 hours of homework, I'm talking about 5 hours of math homework. I don't care about your other classes. Every week, week 1 through week 36, because this is 36 weeks of a school year, you will have 5 hours of homework. During midterms, 5 hours of homework. During spring break, 5 hours of homework. During final exams, 5 hours of homework. That's plan A. You can choose that if you want. Or you can choose plan B. Now, plan B will work like this. During week 1, I will give you 1 second of homework. You're like, how do you do 1 second of homework? You think about math. Done. Cool. During week 2, I will give you 2 seconds of homework. Think about math some more. Good. Done. Here's an A. Here's 100. Because again, all of your grade is based on this homework. All of it. Now, mind you, I assume that I'm going to have like half the class or a portion of the class choose one and a portion of the class choose the other. So everyone is allowed to choose their own individual homework plan. During week 3, I will give you 4 seconds of homework. Write down your favorite number. Done. Here's an A. And this will continue for 36 weeks. Now, you get to choose which plan you pick. But whatever plan you pick, you are not allowed to switch. You can't switch. So let's see. Homework plan. I'll put today's date on there. Option 1 is plan A. Option 2 is plan B. And you can only choose one of the two, basically. I am going to copy this link. Copy. There we go. And I'm going to paste it into the Google Classroom. Plan A or plan B, question mark, paste that, post. What I need you to do, if you're in the classroom right now, I need you to get on those Chromebooks very quickly. You're only going to be doing this one thing on the Chromebook. For those of you on the live stream, I can see you right there. I've already posted the link into the Google Classroom stream. I have also posted the link into the chat right here, obviously. Now, I am going to click a thing saying to collect the emails. And I also should say limit to 1 response. Save. There we go. So I'm going to give you a little bit of time right now. Or a little bit of time, like a minute or two. You have to make a decision. It's September. You walk into my classroom and you are choosing a homework plan. You can only choose plan A or plan B. And whatever you choose, you can't switch it. You can't stop it. You're stuck with it for the entirety of the school year. And this is 100% of your grade. And I'm going to grade every bit of it. So I'm going to critique your favorite numbers. I know, right? Now, if,
See, the thing is one of them seems like a better option, and I know that it probably isn't the better option.
make your choice. Make your choice. So make sure you are clicking plan A or plan B and submitting it. And we'll see what happens. Do 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 do. Yada da da da. Yada da 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 da. Yada da da da. See, for those of you in the live chat, you can't hear it right now, but there are people who are debating their choice right now. I don't know. You have about 30 seconds left to make your choice. Huh? Go to Google Classroom. There should be a link for a Google form. And since you're already logged into your school account, it'll allow you to answer because you can only do it. I collect the emails, whatever.
It's like quality over quantity, basically. It's like a modified quality over quantity type question.
Let's see. So far, I got 8 responses, 9 responses. Keep putting those 10 responses. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there are roughly 1, 2, 3, 4, 6, 7, 8 in the chat there. Okay. Once you have submitted your choice, and this is just for those of you that are here, obviously. Once you submitted your choice, we're done with the Chromebooks. You can close those up. That'd be fantastic. Just so I can see who's done and who's hasn't done it yet, I should say. For those of you in the live stream, obviously you're keeping your Chromebooks open. I got 11 responses so far. Be quick with your responses. I'm gonna shut this thing down so you can't. No one can respond in a few minutes, or not a few minutes, probably like less than a minute. I know. It's. I know. Wow. Inappropriate.
I don't understand that concept. How you tell me what's going on in my house?
Well, I think. Well, no, I was actually going to refer to the other comment that he made. What I was going to say is walking around that way, you got to keep in mind that each of these streams are being recorded, so that they should be for posterity. No, I know, but they should be recording it. We were required to record it in order to make the lesson available for other students who are not there. Yeah, I mean, obviously all of mine are recorded, Now, was it a Dallas Cowboys hat or was it an actual cowboy hat?
Yes, Mike. Yes, Mike.
It was an actual cowboy hat? Wait, it was an actual cowboy hat? Then that's fine. I mean, if it was a Dallas Cowboys hat, I can understand. Sure. All right, I'm gonna close out the responses. Click. I have stopped accepting responses. Let's take a look. Oh, look at that. What? So it looks like, where's my marker here? It looks like 2/3 of you picked plan A and 1/3 of you picked plan B. Interesting. I should tell you, I did this with my other Algebra 2 class, and they went 50-50. You know, but there were 10 responses there. They went 5 and 5, and there were 12 responses here. You guys went 8 and 4. So, what is the better choice? If you would, I'm going to set these up. I'm going to set up a calculator in a minute, but if you would, I'm going to need those notebooks out and open. So, here's what I'm setting up. Here's what I'm setting up. And for those of you in the live chat, I can still see the comments because I have the thing set up at my desk. So I got you right here. Live chat, there you are. Good. Okay, here's my calculator. I'm going to zoom in on this sucker. Okay, first and foremost, if you are going to be choosing plan A, then yeah, you got 5 hours every week. 5 hours at the beginning of the year, 5 hours at the end of the year. Good for you. For those of you who chose plan B, I've heard a lot of different rationale for it. I've heard people say like, hey, it's doubling every week. Yeah, it is. It is doubling. 1, 2, 4. It's doubling every week, but it's still like measured in seconds, right? Some people be like, oh, well, you know, even if it's measured in seconds, it's still not going to be a lot of time by the end of the year because it's still like measured in seconds. It's like, you know, at one point I may have to do a bit more work, but we'll see what happens. Let's see. You start off with 1 second of homework. Then it doubles. And now you have 2 seconds of homework. And then in week 3, you have 4 seconds of homework. And that's all the information I gave you. Now, yes, a lot of you realized that it was doubling. Let's see what happens by the end of the first marking period. The end of the first marking period is 9 weeks into the school year. So 4, 5, 6, 7, 8, 9. Who's calling me? Mr. Marcus room. Hey. I got to get back to you on that. Oh no, I haven't submitted it on there yet. I teach straight through 1, 2, 3, so I gotta go back and double check to see if she was in the live stream then. Okay, bye bye. Why do they keep calling me during class? Like I have things to do, but they're just like, no, answer my question. Anyway, so here we are at the end of the first marking period. 256 seconds. On 256 seconds. Now, 256 is actually about 4 minutes and change. So at the end of the first marking period, you only have about 4 minutes and change worth of homework. What does everyone else have? 5 hours. Huh. All right. 256 times 2. Let's go to midterms. 10, 11, 12, 13, 14, 15, 16, 17, 18. There is midterms. Now, midterms is only halfway through the school year, 18 weeks in. Now, mind you, that's still measured in what, though? Yeah. Divided by 60, there's minutes. Divided by 60, there's, oh, crap. That's hours. Anybody choose plan B? Now, mind you, this is 36 hours worth of homework when you're only halfway through the year, and everyone else, if you chose plan A, you're doing 5 hours. But remember, But you can't change. You can't change it. Hold on. So let's just go to the end of the school year. So 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36.
Wait, what is that?
That is scientific notation. That is 3.4. Hold on. That is 3.4 times 10 to the 10th power. Now, that's measured in seconds. Here it is measured in minutes. Here it is measured in hours. Here it is measured in days. And here it is measured in years. What timeout?
It's gonna be worse for you than us at this point.
Oh, I will grade every bit of it. I will have that much material.
1,000 years of homework.
Get it in.
Actually, I'm good. I got an hour a day. I got an hour a day.
No, because he chose the 5-hour plan.
5 hours a week, an hour a day.
Now, I've heard the phrase. That escalated quickly. And that kind of applies to what we're doing right here. Look at my beautiful face. There you go. Now, this escalated pretty quickly. It does. I've heard similar stories to this of like, there's like an ancient proverb about like a chessboard where you put like 1 grain of rice on the first chess thing and then 2 grains on the second and then 4 grains on the third. And it keeps doubling. Well, by the time you get to the end of the chessboard, there would not be enough molecules in the universe to cover the amount of rice that you would need. Think about that. The amount of rice that you would need by the end of the chessboard, if you put 1 on the first, 2 on the second, 4 on the third, and it kept doubling, by the time you get to the end of the chessboard, which is 64 squares, by the time you get to the end, the amount of rice that you would need would be more than the amount of molecules in the universe. Yeah. Genius would have to grade it all. Yes, of course I would have to. He says that I would have to grade it all. I just said I would before, but anyway, yeah. Yeah. So let's go to our notebooks and let's see where this is going to take us, because this is introducing a brand new chapter to you all. This chapter, there we go. I'm going to call this Intro to Exponentials. Exponentials, that escalated quickly. Exponentials are a brand new type of function that we are going to be facing this year. Now, you might have faced some exponentials in Algebra 1. It depends on who your teacher was. It depends on how far you guys got. It might have been the end of the school year. I don't know. But I'm here to kind of help you get back on top of that information. So let me give you some preliminary information in regards to exponentials. First and foremost, this is a simple exponential. This is just a basic, simple exponential that we have right here. Y equals b to the x power. The thing that I want you to take away from this is the fact that the variable is in the exponent. Thus, we call it exponentials. It's very important to recognize the fact that the variable is in the exponent. B is what we refer to as the base. Now that has implications. Knowing that the b is the base, it does have implications for what I'm going to be teaching you. But that's a very basic exponential function. There are two types of exponentials that I'm sure you've heard the phrasing at one point or another. You've heard the phrasing exponential growth, whether it be the number of grains of rice on a chessboard or the amount of homework that you have to do if you chose plan B, or money left in a bank account over a long period of time, or I don't know where you guys would have any real world basis for this, but I don't know, like a virus kind of, spreading across the globe. I don't know. You nothing? Okay. Just thinking. But seriously, it's an exponential growth. Technically, it's a logistical growth, but that's besides the point. It's exponential up to a certain point until it starts to decline. But now, the other type of phrasing is exponential decay. Exponential decay, if you know anything about science, like radioactive decay, the idea that you guys know about Chernobyl in Russia, right? Yeah. Exponential decay is just the idea that you have to wait a certain number of years for the amount of radioactivity to decline in order for it to be safe for people to go in, because it actually decays at an exponential rate, even though it does take a pretty long darn time. I don't know. Do you guys know about Chernobyl because of that TV show? Okay, just there's a TV miniseries about Chernobyl and what went on there. I saw this documentary about the power plant on 3 Mile Island. It was destroyed by mutants, and the whole thing kind of fell apart. It's great. Yeah. No, like X-Men. Did you never see that movie? There's a movie called X-Men Origins Wolverine.
Oh, I've never seen that.
Whatever. Back to this. Whatever. You watch WandaVision?
Yes, I did.
It is pretty good. They're introducing X-Men in that show. Now they are. Have you watched all of it?
I did watch that.
Oh my gosh.
I have to get to that one.
Watch it! Anyway, if B is greater than 1, then you have what is known as a growth. Now, B will determine whether or not you have a growth or a decay. If the value of B is greater than 1, then you have what is known as a growth. Now, it doesn't matter if it's like 1.1 or 1.001. As long as it's greater than 1, you have a growth. If B, now watch very closely to how I'm writing this. I may say the phrase, if B is between 0 and 1, but look how I wrote it. I said if 0 is less than B is less than 1, meaning B is between those two numbers, then you have a decay. What can B never be? Ooh. What can B technically never be? It can't be exactly 1. It can never be exactly 1. Then it would not be either. It would not be a growth or a decay. What can B also never be? Can't be negative. Can't be negative. It would not be a growth or a decay. What else can it not be? B cannot be 1, negative, or it can't be 0. It can't be 0. According to those inequalities, B cannot be a 1, a negative, or a 0. If the B is a 1, negative, or 0, then technically it is not an exponential growth or decay. Technically, it is not anything. It might be something else, but it's not an exponential. Now, I gave you the simple exponential. But now let me give you the standard exponential. A standard exponential looks like this. Write that down very, very carefully. Let me zoom in on that. This is your standard exponential. Notice the use of H and K. H and K make their return once again. K is way more important than H in regards to these exponentials, which I'm going to be showing you some visuals in a little bit because I really have to talk about what the heck is going on here. But I need to show you some visuals. The B is still your base. This A, yes, it's being multiplied by the base, but technically you need to keep them separated. You do need to keep them separated. So, let me go to Desmos real quick, and let me show you something. Actually, you know what? I'm going to go to my calculator, not Desmos. I'm going to go to my calculator. Here we go. Zooming in, zooming in, zooming in, zooming in, zooming in. And let me put this one on here. There we go. Look what I'm putting into the calculator right now. Chapow! There it is. Let me take away these axes. Watch this. This is the general shape of an exponential. Now, I need you to understand something about the shape of this exponential. I'm going to be drawing out some of the shapes in a little bit, but I need you to recognize something very important about this. Yes, it starts out slow, 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 builds up a little speed, and then all of a sudden, kapow, it skyrockets. That is exactly what happened if you chose plan B. Just saying. That's exactly what happened. Started out slow, slow, slow. By the end of the first marking period, you're only at about 4 minutes of homework. And then, what the heck, midterms? What the heck, the rest of my life? That's what happened. But what is happening to this curve as you go to the left? What is happening to this curve as you go to the left? I'm going to disagree with you there. It does keep getting lower. But let me show you what the heck is happening. Look at my calculator. I'm about to type some stuff into this thing. Watch this. Trace 1. Look right there. I've highlighted a point on my graph, and you can see at the bottom of my screen, it's 1, 1. That is week 1, 1 second of homework. Week 2, 2 seconds of homework. Week 3, 4 seconds of homework. Week 4, 8 seconds of homework. What is happening to the amount of homework that you have? What is happening to the number of seconds of homework that you have to do? It's doubling though, right? It's going up, but it's doubling. As I go to the left, it's being cut in half. As I go to the left, watch this, 0.5, negative 1, 0.25, negative 2, 0.125. Now, what you just said before, I want to clarify because that's what a lot of people think. A lot of people think that it just basically goes and it just kind of just stops and goes horizontal. Technically, it doesn't. Technically, it doesn't. You can't, on this one, you can't. On this one, you can. Correct. Correct. And you also can't have no homework. So, imagine for a moment. Now, for those of you in the live chat, I apologize. You will not be able to visibly see this experiment, but you'll be able to hear me. Imagine, for all of you that are here, imagine that I am roughly, I don't know, like 8 feet away from this door. Imagine that I'm 8 feet away from this door. I'm going to play a game with myself where I walk half the distance and then I come to a stop. So if I'm 8 feet away from the store and then I walk half the distance and then come to a stop, how many feet am I away from the door now? Yeah, 4 feet. That was simple. Yay! I'm going to do it again. Walk half the distance and stop. How far am I away now? 2. Half the distance and stop. half the distance and stop. Half a foot, half the distance and stop. 0.25 or 1/4.
It'll just keep getting smaller and smaller. You'll never get to the door because it'll keep getting smaller.
That's the key. It would go 1/4, 1/8, 1/16, 1/32, 1/64, 1/128, 1/256, 1/512, 1/1024, 1/2048. It'll keep going because I'm a genius. It'll keep going and going and going and going. But the key is what you just said before, what you guys were just saying before. Theoretically, now mind you, theoretically, I'll never reach the door. Now, quite literally, it's like, I got it, I'm there. But no, the rule is I walk half the distance and stop. But there will always be some positive distance between me and the door. Some positive distance between me and the door. The distance between me and the door will never actually reach 0. Those are fun. Yeah. But here's the thing, though. Now, the only way I would actually reach 0 is if I could take an infinite number of steps. But infinity is not a number, and I'm never going to be able to take an infinite number of steps. The idea, now watch this. Here's a key word that I'm going to throw at you. Ready? Maybe you've heard this word. Maybe you've never heard this word, but here's a brand new word for some of you. What I'm doing is I'm actually approaching what is known as an asymptote. An asymptote. Yes, Mr. Markey, you're being a real asymptote right now. Ooh, what does that mean? No, this is an asymptote. Not an, I know. Isotope, asymptote sounds very similar, but this is an asymptote. So, first, let me give you a visual representation of the types of growths and decays that we could potentially have. Let's see here. Come on, paper, be my friend. Zooming out. Here we go. First of all, there's 2 visual representations of a growth that I need you to write down. 2 visual representations. One of them looks like this. Now, notice to the right, as I'm moving to the right, this thing kind of like skyrockets. To the left, I'm going to use the word that it flatlines. It flatlines. Keep that in mind. It doesn't curve back up, and it doesn't drop lower than the flatlining. Now, mind you, I can actually shift that asymptote. I could shift that asymptote up and down, but I'll show you that in a little bit. Yes, I will, after I do this, because I do have a definition that I got to write down. The other type of growth that you might visually get is this. Mr. Markey, that doesn't look like a growth to me. It's clearly going down. I know. It's still a growth, though. Mr. Markey, how can things grow in a negative direction? I don't know. How about the national debt? Right? Oh, it's money we owe other countries. And the interest that is accruing. Never going to be paid off. Yeah. We owe trillions of dollars to other countries. Well, it's like Japan and China and stuff like that, and India and Russia and I don't know, France maybe. Until when? You said until when? Until, I don't know if she said we were going to talk about the other countries like defaulting or calling in their loans or some junk like that. I don't know. But I'm just saying, it could be something like that. The amount of debt that you owe. I don't know. Anyway, but those are 2 different types of growths. Things that grow over time, either in the positive or negative direction. So what does a decay look like? A decay is something that flatlines. Flatlines going to the right. A decay is something that could look like this. It's supposed to flatline. You guys heard of like carbon dating and stuff like that? Carbon dating is a form of exponential decay. They figure out how much carbon is in the object currently, and they work backwards to figure out when the thing was alive. It's pretty crazy. Unfortunately, it is difficult to accurately measure the minuscule amount of carbon left in an object. You know what I'm saying? So unfortunately, like for like a dinosaur, for example, they're like, well, it could be anywhere between 30 and 60 million years old. That's a huge time frame. I'm just saying. Anyway, it's just an estimate. Here's another type of exponential decay. Something that flatlines to the right. Oh, goodness. So let's see what we got here. Total side note, I was just thinking about this homework thing because there's a comment in the chat saying like, yeah, that Mr. Markey would have to grade it all that homework that you guys did if you're doing the 1,000 years. No, but here's the thing. What would you actually turn in?
That's the better option.
No, I'm just saying, what would you actually turn in though? Yeah, if you had 1,000 years worth of homework to do and you knew that your grade depended on it. No, not until you pass my class.
Who would have dropped out?
Yeah, you don't graduate. Okay, then
I dropped out. It was like,
So at any point, would I have to grade 1,000 years worth of homework based on your arguments? You would actually get it done. No, I'm going to outlive all of you. Well, no, I'm going to outlive. No. The vaccine's not going to make me a genius. The vaccine's going to make me a superhero. But no, the reason why I'm going to live forever is just because I'm going to make sure it happens. Or I'm sorry, outlive all of you. I'm going to make sure it happens. I never said that.
I'm black. I can look better. Black don't crack.
A duel?
A duel? Like with swords?
Remember when it was legal to shoot someone dead in the street?
What?
It was never legal to do that.
People still did it all the time. They challenge people to a duel, have the doctor turn around, shoot them in the head, and then that was it. Like, and then go get a beer on a Tuesday. Like,
I feel like you guys have like romanticized Hamilton, you know?
Theater nerds. Nerds.
Anyway, back to this.
That's gross.
Ladies and gentlemen, I'm writing down some information that you need to do. This is going to answer the question that was posed. Hey, what exactly is an asymptote? Well, an asymptote is an invisible barrier that the graph approaches but never crosses. Let me repeat that. An asymptote is an invisible barrier that the graph approaches but never crosses. Now, that definition may have to change for future chapters outside of exponentials, but for exponentials, that's 100% true. Now, y equals k, whatever the k value is what is known as the horizontal asymptote. Let me give you an example here. We are going to graph something together. Y equals 2 to the x power minus 3. Y equals 2 to the x power minus 3. Now, first and foremost, can you tell me whether or not this is going to be a growth or a decay? Can you tell me whether or not this is going to be a growth or a decay? Based on the way the equation looks. Why? Not just because it's positive.
well, that's why I say
It is a growth.
it. And the X is positive?
Nope, it has nothing to do with that. It is a growth, but it has nothing to do with the 2 being positive. It has everything to do with the fact that 2 is greater than 1. Because remember, if my b value were, give me a number between 0 and 1.
Can I? Oh, sorry.
0.2567.
All right, 0.25 and change. That would be a decay. Is 0.25 and change a positive number? Yes, it is. But it would be a decay because that b value would be between 0 and 1. But this b value is equal to positive 2. And because it's equal to positive 2, it is a growth, not because it's positive, but because it's greater than 1. That's the reason why. In fact, for this particular graph, this is actually going to be doubling values over time. Yes? Oh, well, let me show you a visual. Let me show you a visual. Ready? This is hopefully going to help a little bit. Go for it.
I don't even know, like, what I'm confused on. Normally, if I'm confused, I'll, like, at least be able to know what I'm confused about, but this is all just words and numbers.
Well, hold on. Now, let me tell you one thing, though. Ready? Number one, this is just an introduction to the brand new chapter. This is just introductory material. And this is material that some of you have never been exposed to. Just because you don't understand it within the first 30 minutes of seeing something doesn't mean it's impossible. It just means that you're not used to it yet. Just saying. Well, you know what I did when I was a baby? I just stood up and walked. No, I didn't. I didn't stand up and walk. What did I do?
You put on your suit, got your briefcase, and said, you probably actually rolled around on your stomach for a couple months.
No. What did I do when I tried to walk?
You fell on your face.
Is that so bad?
Absolutely embarrassing. That's why I have this.
As a baby, you have to learn.
Babies are like stupid and like they fall out.
You know the point I'm trying to make, though.
Yeah, but, like,
The point I'm trying to make, just for clarity,
falls on its head, like, on the concrete, and then it dies.
is the fact that when you are learning to walk, nobody does it perfect the right time.
Rewind that comment, though.
Which comment?
Wait, can I ask a question? Legally, if your child, like, can't walk and, like, it's trying to, outside, let's say, and your baby trips and falls, lands on its head, and, like, just dies, like, do you go to jail for, like, not taking care of your kid? Or is it, like, accidental? If you
That
can-
is not.
You can prove it was an accident.
That is not for me to decide. I do know that babies are very versatile. Babies, when they trip and fall, like they smack, like think of like a little kid, like they smack their head and like bump their legs into things, have black and blues on their shins, like every other day. My kid, yeah, exactly. They're very tough, but they're kind of built that way. It's a baby. Anyway, back to this. Now, to clarify about your number, you said like -5, right? Watch this. This is the growth that we're going to graph in a few moments. And you can see this thing, it's been shifted, blah, blah, blah. It still follows the rules of a growth. It still skyrockets. It still flatlines to the left, the whole thing. But now, let me change that to a -5. Now, you notice how I put the -5 in parentheses. Now, according to the rules that I wrote down earlier, I said that if it were to be a growth or a decay, then the b had to be greater than 1, or it had to be between 0 and 1, right? Remember what b can never be? What would happen is this. Absolutely nothing, because you can't graph it. It's not a growth or a decay. It's nothing. It's literally nothing.
Well, it's gotta be something. Nothing can that. It's a line.
It's not a line. It's not a curve. It's not a continuous function. It's just a random assortment of dots. That's all it is. Yeah. So, back to this.
I've never dropped a baby. I'm just asking.
Me either. What?
Y equals -3 is the asymptote. Now remember that I said that when it came to asymptotes, they are going to be something like invisible barriers that the graph approaches but never crosses. In this case, because I can identify the asymptote to be -3, and I'll show you something on the calculator in a moment, I know it's invisible, but I'm actually going to put this asymptote in there like a dotted line. I'm going to put it in there like a dotted line, knowing that, okay, that's the asymptote. That's the barrier that the graph is going to approach but never cross. Now, how do I graph this accurately? In order to graph this accurately, I am going to go to my calculator's table of values. I'm able to identify, based on the equation, the fact that it is a growth and the fact that y equals -3 is the horizontal asymptote, just solely based on the b and the k of the equation. I type this into my calculator, and I'm going to go to my table of values real quick, and I need you to see something. First of all, look what happens when I go backwards in the table of values. I'm going to zoom in a little bit more. Look what happens when I go backwards in the table of values. What's happening to the y values? What are they getting closer to? What are the y values steadily getting closer to the more I go up? Say it louder. -3. They're getting closer and closer to -3. Remember, the invisible barrier that the graph approaches but never gets to, never crosses, never reaches. Now, if you see it right here, if I click over, look at that number at the bottom of the screen, -2.9999. If I go up, eventually the calculator says, it's -3, but it's not. Look what happens when I go over the -3. It's not -3 yet. Watch what happens when I go back up here. Look at that. It's not -3 yet. I keep going up. It never will. Now, the calculator at some point gives up because it can't handle that many digits. So the calculator at some point will just say -3. But you know, and I know, that it will never actually get there. It'll give up and just say -3. But you should know that the calculator's not right. It just ran out of memory. That might be the closest we're going to get. Oh, there it is. But you see what I'm saying? It's not actually there yet. It'll never actually reach -3. But at a certain point, the calculator does give up because it can't handle that much memory. It's pretty crazy, actually, how much this thing can actually do. Did you know that this graphing calculator has more computing power than the Apollo 11 space mission? Think about that. This calculator has more computing power than the Apollo 11 space mission. Not like rocket fuel power, but computing power. No, it means that technology has advanced. This came out 30 years after we went to the moon. Anyway, now in order to graph this, I am going to have to get some numbers on here. So I'm going to go with 0, -2, and 1, -1, and 2, 1, and 3, 5. You can see me putting those numbers right here on my curve. There they are. But the thing that you have to recognize, to the right, yes, this thing is going to be an exponential growth. But to the left, what is the phrase that I told you to the left? What is the graph doing as it goes to the left? What happens to your heartbeat when you die? It flatlines. You ever seen those heart things that go exactly the E? That's the flatlining. This thing flatlines going to the left. Do not let it cross that asymptote. Do not let it curve back up. It flatlines. It'll never actually reach the asymptote. It'll never will. But it flatlines. Let's talk very briefly about domain and range, and we'll be done for the day. I say very briefly because domain and range will only take a few moments. First of all, domain. How far left and how far right does this graph go? Simple answer. How far left does it go? Not -2 to 4 to the left. That's what I drew. It does, forever. To the left. And what about to the right?
It doesn't go any further right. It just keeps going further up.
But it goes up and right. Yeah, it does. Like, for example, think of the homework example. I stopped at 36 weeks, but technically, couldn't I have kept going? Yeah. The domain is -infinity to infinity. In fact, all exponentials will have that same domain. They will. Domain is left and right. Domain is inputs. Domain is x values. Now the range is up and down. The range is y values. The range is outputs. How far up does this thing go? Infinitely. How far down does it go? It'll never get to -3. It'll never get to -3. It'll get as close as humanly possible to -3, right? When we did square root functions, I would normally put a bracket around this thing, but I'm putting a parenthesis because it will never get there. Because I can open or close circle. Please make sure that you have done that assessment for me. You have a major, and we will pick up with this. Technically, we'll pick up with this on Friday. You will have something in Google Classroom on Wednesday. If you haven't left a comment, make sure that you do so. You guys ever see Futurama? No? There's an episode in season 1 that deals with exponential growth with the money in his bank account. I'm being serious. So, no, for real, there's an episode where he realized